Hi, a very warm welcome to all of you. Let me start with a brief introduction about myself. I've got 6 plus years of experience in the IT world. It's been very long since I've been working in big data domain. Right now I'm working with one of the renowned player in big data at their Noida location. I'm also Hortonworks certified Apache Hadoop developer. Let's start with the Hadoop introduction. Before jumping directly into Hadoop, let's first discuss DFS. Why do we need DFS? DFS is distributed file system. Hadoop is also based on distributed file system principle. Let's discuss this simple mathematical problem. Suppose we have 1 terabyte of data to read, and then we have one machine having 4 hard disks, 250 GB each. This way we have divided our 1 TB data. Again I am repeating, we have 1 TB data to read. We have 4 hard disks, 250 GB each. So we'll be able to divide 1 TB data in one machine. Now we are considering that disk reading speed is 100 Mbps. Now if we have to read the complete data, how long it will take? Since we are keeping 4 hard disks which are running parallelly, or I would say there are 4 input output channels, so now we have to just focus how long it will take to read 250 GB as 4 hard disks are running parallelly. So let me reveal the answer. If 1 second is taking to read 100 Mbps, so 10 seconds will take to read 1 GB. So if it is taking 10 seconds for 1 GB because it is reading 100 Mbps per second, so it will take 250 into 10, 2500 seconds to read 250 GB data. So let me summarize. We had a 1 TB data in one machine. We had 4 hard disks having 250 GB each. We are running 4 hard disks parallelly or keeping 4 input output channels. We have taken the assumption that disk reading speed is 100 Mbps. Now we have calculated that if disk reading speed is 100 Mbps, so it will take around 41.6 minutes to read 1 TB data in one machine. Now let's say I would divide this data into 10 machines. Now if we are having 10 machines, if we have 1 TB data, so we can keep 100 GB on one machine, right? 100 into 10, this way we'll be able to divide 1 TB data. So now we are taking the same assumption. In one computer we are having 4 hard disks, right? So now if I'm having 100 GB on one computer and if I'm keeping 4 hard disks, if I have to divide 100 GB into 4 hard disks, so that would be 25 GB in one hard disk. So this way I'll be able to divide the 1 TB data. What I have done, instead of using one machine, I have divided the data into 10 machines where I'm keeping 100 GB on one machine and 25 GB each on hard disk. If I'll keep the same 100 Mbps speed for reading, so how long it will take? So it will take 1/10 of that time which it was taking for 250 GB, right? Because we have divided our data into 25 GB into 4 hard disks. So this way we'll be able to reduce the time by 1/10. Means earlier it was taking 2500 seconds, now it will take 250 seconds. So as we can think, so in 1 TB it is taking 41 minutes to read, right? For big data this is not a good case at all. In big data we deal with PBs of data. So if we have to deal with 100 dB 500 dBs data, so we won't be able to process data in one machine because we won't be able to get relatively quick result in one machine. So we'll have to use a distributed file system where we can parallelly keep the data and then process the data. So we need to have distributed file system so that we can divide our big data into small chunks, and then that small chunks can be used for parallel computing. What is the motivation for Hadoop? First point is scalability to large data volumes. As we saw in the last slide, if we were only reading 1 TB of data in one node, it was taking around 40 plus minutes. And when we divided that 1 TB data into 10 machines, it was taking close to 4 minutes. So that way we were able to reduce 1/10 of that time. Assume it, suppose you have to read 100 TB data, and that too you are using only one node, we are considering the same disk reading speed, that is 100 Mbps. It will take you to read around 12 days. And instead of keeping one node, suppose you have divided that 100 TB data into 1000 nodes cluster, so it will take around 16.5 minutes. So you can very well see the difference. It is taking 12 days, and relatively on the other side it is just taking 16.5 minutes. Second could be cost efficiency. So Hadoop can very well work on commodity nodes. Commodity nodes means you don't need any fancy hardware. A decent configuration would work for you. Even if Hadoop can very well work on your laptop, very well work on your desktop, maintaining decent configuration. So as we are using commodity nodes, so they are cheap. Obviously they are unreliable. So this could be the challenge, right? Suppose you are using one machine, so there is a probability that this machine fall down maybe once in a year, or maybe twice in a year, or maybe once in a 2 years. But suppose you are maintaining 1,000 nodes cluster, so there is a probability maybe day or the other any machine, maybe one or the other machine may fall down. So this point has been very well taken in Hadoop. So solution could be, you should build a fault tolerant into the system, so that if one node goes down, so it should automatically take care of that. So Hadoop is based on this principle. So if we are using commodity network, so challenge could be commodity network having low bandwidth. Solution which has been taken in Hadoop is push competition to the data. So this means, suppose you have data at one node. In most of the cases, what Hadoop will do, it will try to process that data in that node only, in that place only, instead of copying the data from one place to another, or instead of copying data from one node to another node. So it will try to avoid this network transfer. So this way commodity network works very well with the Hadoop. So let's discuss Hadoop timelines, how Hadoop came into existence, why do we call it Hadoop, how it got mature, everything. How Hadoop came into existence is all about, if I talk in layman language, Hadoop is all about two things. First is storing the big data or storing the bulk data. So that is being taken care by Hadoop distributed file system, which is HDFS. And second is, so if you are storing the data, obviously you have to process the data. So if you are storing just for the sake of storing, if you don't want to process the data, you shouldn't use Hadoop, you shouldn't store that data. So first part is storage, which is being taken care by HDFS, Hadoop distributed file system. Second part is MapReduce, which is a processing part of Hadoop. Late 2003 and early 2004, Google published two papers. One was based on Google file system and another was based on MapReduce. So HDFS is based on GFS and MapReduce is based on Google's MapReduce paper. Doug Cutting and his colleague Mike, they were working on Apache Nutch project. Doug Cutting used DFS and MapReduce to support to Nutch. Doug Cutting has a son. He had a toy yellow elephant. He used to call him Hadoop. So this is how the name of Hadoop came into existence. Doug Cutting joined Yahoo. Then Yahoo did some experiment on Hadoop. First they did sorting on 1 TB data, maintaining 910 nodes. It took around 3.5 minutes in 2008. They had broken their own record. In 2009, keeping 1460 nodes for 1 TB data, it took them 62 seconds. And then they sorted 1 PB data in 16.25 hours, maintaining 3658 nodes. So during this timeline, Cloudera was founded, it got open source, Facebook launches Hive, SQL support for Hadoop. So this was the main time where Hadoop got mature. As we can see, so if even we compare with aircraft with cargo train, we know aircraft is refined, very fast, it provides lot of add-on features. But if we talk in terms of price, it is pricey on a per bit basis. This is very expensive to maintain. On the other side, cargo train is rough, though missing a lot of luxury. Yes, slow to accelerate, but it can carry almost anything, and once it gets going, it can move a lot of stuff very economically. So if you're dealing with a small data set, if you're dealing with structured data, if you have to think in terms of ACID properties, means dealing with transactional data or banking domain, then you can go with the relation databases, because so you'll be getting result in a interactive response time in a real time. But suppose you have to deal with the big data and you have to consider the cost also, so Hadoop is the best choice. As we have discussed, it works on commodity hardware. It can work on any data. Data shouldn't be in structured. It can work on structured data, semi-structured data, or unstructured data. We have also seen it works on horizontal scalable principle. So you can add as many machines as you want. So if one machine goes down, so it will also take care of that. You can very well scale Hadoop, RDBMS. So there is a problem of scaling and there is a problem of costing. Thanks for your time. I'm hoping you would get at least basics of Hadoop out of this session.